Hello everybody, this is Vipul Purohit and I welcome you back to my YouTube channel. In this video, we are going to discuss about the third part of the molecular orbital theory of polyatomic species. Okay, I am sure you have seen the first two parts. Okay, नहीं देखा है आपने? No worries. Okay, description box में आपको वो दोनों previous part का part 1 और part 2 का link मिल जाएगा, तो आप देख लीजिएगा. Okay, because it's a continuation, so it's always better that you go through it. Okay, मैंने आप लोग को introduction part बताया था, that is about SALC, and then we discuss about the beryllium hydride molecule. So in this video now, we are going to continue with the same chapter, and that is about the bonding in water molecule. So we begin with the bonding in water molecule, that is H2O. Now सबसे पहले दोस्तों एक बात याद रखिएगा, मैं इसे hydride of oxygen नहीं बोलूँगा. Okay, in the previous case I told you about beryllium hydride. Okay, but here I cannot call it as oxygen hydride. No. The reason is because when I talk about hydride, it means that when the bond breaks, they should release what? H minus. Okay, वहाँ पर होता था ऐसा because the hydrogen was being attached to beryllium. Okay, and beryllium is highly electropositive as compared to that of hydrogen. Okay, so therefore when the bond breaks, it releases H minus. Okay, और इसलिए हम उसको hydride बोलते हैं. लेकिन यहाँ पर the hydrogen is attached to oxygen. And oxygen is more electronegative than hydrogen, and therefore we don't call it as a hydride of oxygen. Alright, I guess the concept is clear. Alright, so now we go into the next part, and that is of course the bonding part. Now those who have seen the first two parts of this particular chapter, then probably you will understand very well, okay, how the introduction goes is, okay, we are first of all going for SALC, और उसके बाद हम improvements देखेंगे अगर ज़रूरत है तो SALC के मुताबिक पहले तो हमें सेंट्रल एटम डिसाइड करना है. ओके, और मैंने आपको बता दिया था कि द एलिमेंट हुज प्रोपोर्शन इज गोइंग टू बी 1 इज गोइंग टू बी कंसीडर्ड एज द सेंट्रल एटम, एंड देयरफॉर यहां पर कौन होगा? ऑक्सीजन. और अगर ऑक्सीजन सेंट्रल एटम है तो ये बात भी तय हो जाती है कि हाइड्रोजन एटम्स आर पेरिफेरल एटम्स बिकॉज़ द रिमेनिंग एटम्स आर पेरिफेरल एटम्स. ओके, सो दैट इज द फर्स्ट पॉइंट दैट यू नीड टू से, दैट ऑक्सीजन is considered to be the central atom and the two hydrogen are going to be called as the peripheral atoms, or I also call it as the surrounding atoms. Okay, उसको दूसरा नाम क्या दिया जाता है? Surrounding atoms. ठीक है? Okay. Next is अब हम electronic configuration देखेंगे of the central atom as well as the surrounding atoms. तो central atom में oxygen atomic number is 8, तो उसका valential configuration हो जाएगा 2s2 and 2p4. I'm using the word valence here, my dear friends. Okay, I'm ignoring the first share. So it is 2s2 as well as 2p4. और जहाँ तक हाइड्रोजन का सवाल है, so let us consider hydrogen as Ha and Hb. Atomic number is 1, so it's very easy. It is 1s1 and 1s1. All right? Okay. So this is the electronic configuration of the central atoms as well as surrounding atoms. अब क्या करेंगे? हमें तो मॉलिक्यूलर ऑर्बिटल फॉर्मेशन के बारे में बात करनी है, लेकिन क्या दोस्तों मॉलिक्यूलर ऑर्बिटल फॉर्मेशन डायरेक्ट होता है? जी नहीं, आप जानते हो ये. यस, ओके, पहले ग्रुप ऑर्बिटल बनेगा और ग्रुप ऑर्बिटल के बाद मॉलिक्यूलर ऑर्बिटल बनेगा, तो ऐसे स्टेज वाइज जाना है. अब ग्रुप ऑर्बिटल बनाने के लिए कौन से ऑर्बिटल्स हमें कंसीडर करने हैं? जी हाँ, कौन सा? यस, ऑर्बिटल्स ऑफ सराउंडिंग एटम्स. And the number of orbitals of the surrounding atoms involved in the mixing, involved in the overlapping, that many number of group orbitals are formed. ओके, ये आपको याद रखना है. अब यहाँ पर तो पेरिफेरल एटम्स और सराउंडिंग एटम्स तो हाइड्रोजन है और इसके पास एक ही ऑर्बिटल है, तो बहुत इजी हो जाता है फिर. ओके, दो हाइड्रोजन के पास दो ऑर्बिटल होगा, क्योंकि अगर एक हाइड्रोजन के पास एक होता है तो दो हाइड्रोजन के पास दो ऑर्बिटल होता है, तो इस तरीके से ये दो ऑर्बिटल मिक्स होंगे एंड इट रिजल्ट्स इन द फॉर्मेशन ऑफ टू ग्रुप ऑर्बिटल्स. ऑलराइट, नाउ यहाँ पर वी टॉक अबाउट द वेव प्रॉपर्टीज. Okay, because whatever these properties are is based on waves, so we call the word wave functions. और wave function का symbol भी आप जानते हो अच्छी तरीके से. जी हाँ, psi. So इस तरीके से what we say is 1s and the 1s orbitals mix, resulting in the formation of two group orbitals. Okay, and these are being denoted as psi1 as well as psi2. अब इसे ग्रुप ऑर्बिटल्स क्यों बोला ये भी मैंने आपको बता दिया था. Those who have seen my videos of the first two parts, और नहीं देखा है तो no worries. ओके, मैंने आपको ऑलरेडी बोल दिया हुआ है कि यस, उसका डिस्क्रिप्शन बॉक्स में आप देखिए, इस वीडियो के डिस्क्रिप्शन बॉक्स में, तो आपको ये दोनों प्रीवियस पार्ट के वीडियोस के लिंक मिल जाएंगे. ऑलराइट, आई एम ट्राइंग टू मेक इट एज सिंपल एज पॉसिबल फॉर यू ऑल. ओके, सो बिकॉज इन माय चैनल देयर आर गोइंग टू बी अराउंड मोर देन 30 प्लस वीडियोस, तो कहाँ आप सब ढूंढते बैठोगे, इसलिए मैंने ये आपके लिए ये सरल करके दिया हुआ है, तो प्लीज आप देख लीजिएगा. ओके, सी द एंटायर वीडियो सो दैट यू विल अंडरस्टैंड एवरीथिंग. ओके, सो कमिंग बैक इज दो ग्रुप ऑर्बिटल मिला हुआ है. ग्रुप ऑर्बिटल्स क्यों बोला जाता है? बिकॉज इट डजंट कंटेन द ऑर्बिटल ऑफ द सेंट्रल एटम. ओके, मॉलिक्यूलर ऑर्बिटल्स की खासियत ये है कि इट शुड कंटेन द ऑर्बिटल्स ऑफ ईच एंड एवरी स्पीशीज व्हिच आर इन्वॉल्व्ड in the formation of that molecule, or I will call it as constituent species. So the orbitals of all the constituent species must be involved in combination, then I call it as what? Molecular orbitals. But here in this case, the combination is not involving the orbitals of oxygen, and therefore I just simply give a word as what? Group orbitals. Okay, and that is being denoted as what? Psi1 as well as Psi2. तो यदि मुझे इस ग्रुप ऑर्बिटल को मॉलिक्यूलर ऑर्बिटल में परिवर्तित करना है दोस्तों, तो जाहिर सी बात है इस ग्रुप ऑर्बिटल के साथ मैं मिक्स कर दूंगा यस ऑर्बिटल्स ऑफ द सेंट्रल एटम. अब देखो आपको कैसे अच्छा याद आ रहा है. ओके, बेरिलियम हाइड्राइड में बताया था ना मैंने, सब वैसा का वैसा यहाँ पर भी. ओके, सिर्फ वहां पर बेरिलियम वाज द सेंट्रल एटम, यहाँ पर ऑक्सीजन इज गोइंग टू बी द सेंट्रल एटम. एंड ऑफ कोर्स देयर इज सम डिफरेंस इन द इलेक्ट्रोनेगेटिविटीज एंड ऑल. सो वो तो हम लोग मॉलिक्यूलर ऑर्बिटल डायग्राम जब मैं ड्रॉ करके दूंगा आपके सामने, तब मैं आपको उसके बारे में बताऊंगा. ओके, लेकिन द इनिशियल पार्ट इज गोइंग टू बी द सेम. ठीक है, सो व्हाट वी डू नाउ इज दिस टू ग्रुप ऑर्बिटल Psi1 and Psi2. Okay, first of all I show you its pictorial representation. Okay, how it is going to be shown? It's an s orbital. Hydrogen है तो s orbital है, और s orbital है तो spherical है. So whenever the two orbitals are going to meet each other, तो मैंने आपको याद रखने के लिए बोला था कि no matter whatever is strong the friendship is going to be, but then no two best friends is going to think exactly same always. नहीं होगा ऐसा. In most of the situations they will be thinking together, yes, the line of thinking matches and that's why they are very strong friends, but then always no. So most of the time it's going to be having the same ideology, sometimes it will have a different ideology. The same thing happens over here also. When the orbitals approach each other, okay, one combination will be with same sign and the other will be opposite sign. ये ठीक है? Alright, so we go into I show here Psi1, I show Psi2. Okay, I show here HA, I show here HB, and one is orbitals. Okay, because it is s orbital, so I'll show spherical. So we now see into the approach of the 1s orbital of HA and the 1s orbital of HB. They approach horizontally. So first combination is same sign. Okay, same sign means you know very well. Sign matlab directions. All right. So this is plus and this is plus, and it is s orbitals are spherically symmetrical, my dear friends. And when they are spherically symmetrical का मतलब ये होता है दोस्तों, not only it is going to be symmetrical with respect to the shape, but also it is symmetrical with respect to the sign. यानी ऐसा नहीं कि ये प्लस साइन जो मैंने यहाँ पर दिखा हुआ है वो इतने ही एरिया में प्लस साइन है, नहीं. द प्लस इज थ्रूआउट द एंटायर स्फीयर. ओके, ये बात आप याद रखिएगा. Okay, next one is we go into Psi2. One combination is going to be with same sign, the other combination is going to be with what? Opposite sign. तो क्या आ जाएगा? इधर प्लस होगा तो इधर माइनस हो जाएगा. Done? Alright, so this is the combination which is going to be obtained for the group orbitals. One with combination with the same sign, other combination with opposite signs. ठीक है? अभी we go into the orbitals of central atom, because at the end of the day our purpose is what? To understand the molecular orbital. Alright, so as a result of which molecular orbital formation will take place when I consider the orbital of the central atom. Okay, so we consider 2s and 2p. Okay, दो orbitals है इसके. So first we start with the 2s. Okay, this is the 2s orbital. I show a positive sign. Okay, next is we talk about the x, y and the z axis like this. If you remember, I have told you everything. So this is going to be the z, this is x and this is y. Okay, so p orbitals dumbbell shape होते हैं, तो मैं ऐसे बताता हूँ, दो लोब्स हैं उसके, और ये ऐसा डायरेक्शन है, तो आप देख सकते हो यहाँ पे क्या हो जाएगा? 2pz हो जाएगा. ओके, नेक्स्ट इज वी हैव, ओके, ये इस डायरेक्शन में है तो ये हो गया 2px, एंड द लास्ट डायरेक्शन इज this way. Okay, this is to be y. Okay, so this is horizontal. Next one, this is vertical. और ये जो lobes है, okay, don't think that y is going to be between x and z. Okay, I told you in my previous video as well. Okay, इसमें क्या हो जाता है कि it is front and back because it is 3-dimensional. Okay, तो ये बात आप याद रखिएगा. So अभी दो lobes हैं. So obviously I cannot show plus and plus is same sign because if it is same sign, so they will combine with each other and it will show like this. So because they got two individual identity, okay, as two different lobes, so it's obvious कि वो दोनों combine नहीं होंगे. और combine नहीं होंगे मतलब क्या हो गया, उसका sign क्या होगा, opposite. तो इसलिए एक को प्लस बताएंगे, दूसरे को माइनस बताएंगे. ओके, फिर उसको ऐसा रोटेट कर दे तो यहाँ पर ऊपर प्लस आएगा, इधर माइनस होगा. फिर इस लूप को पीछे लेके जाएंगे और ये आगे की तरफ आएगा. सो दिस विल बी प्लस एंड दिस विल बी माइनस. अंडरस्टूड दिस? ओके, सो दीस आर द साइंस ऑफ द ऑर्बिटल्स. ठीक है, अभी नेक्स्ट पॉइंट इज when you go into SALC, the formation of molecular orbitals is based on what? Symmetry. कैसे बनेगा molecular orbital? Combination of group orbital with the orbital of the central atom. तो पहले psi1 देखते हैं. Okay, have a look at psi1. There are two lobes. Okay, both of them have the same sign. So when they approach horizontally, that means I can say along the z-axis. So both the signs are same and therefore they will combine with each other. And when they combine with each other, having a positive sign, so they will look like this. Okay, ये दोनों जब combine होंगे तो वो इसके जैसा दिखेंगे क्योंकि दोनों का sign same है तो वो combine होना जरूरी है. Alright, so it will resemble like this. तो ये हमें मिला पहला combination and that results in what? The formation of a molecular orbital. So therefore what we say is the combination will result in psi1 and 2s. It will result in one bonding and the other will be anti-bonding. So I'll say sigma 2s and sigma star 2s. अब दोस्तों ये मैं एनर्जी के हिसाब से नहीं लिखा, पहले बोल देता हूँ, नहीं तो आप बोलोगे सर ये स्टार मतलब एंटी बॉन्डिंग वो नीचे कैसे गया और ये विदाउट स्टार है तो बॉन्डिंग है तो ऊपर कैसे गया. आई एम नॉट शोइंग विद रिस्पेक्ट टू एनर्जीज, प्लीज रिमेंबर दिस. ओके, सो दीज आर द टू मॉलिक्यूलर ऑर्बिटल्स वी गेट. अब नेक्स्ट इज psi2. psi2 में भी प्लीज इमेजिन दैट द टू ऑर्बिटल्स आर अप्रोचिंग हॉरिजॉन्टली, वन विद अ प्लस साइन अदर विद अ माइनस साइन. कंबाइन होगा? नहीं होगा. So when they approach each other, okay, because the signs are different, they will resemble as two different lobes. कैसे वो इंडिकेट करेंगे as two different lobes? और वो भी मैं आपको ओरिएंटेशन बता देता हूँ because that is so very important with respect to the axis. ये जो दो lobes है, one will be on the left and the other will be on the right. One on left, another on right. ऐसे अप्रोच हो रहा है ना. तो वैसे ही मुझे यहाँ पर भी चाहिए. I want two lobes, but listen to the orientation very well. Okay, I am being very specific. There are two lobes, but then the specificity is with respect to what? Arrangement. One on left and the other on right. तो ऐसा कौन सा मैचिंग वाला मिलेगा? जी हाँ, 2pz मिलेगा. इधर भी है दोस्तों, देखो यहाँ पे भी दो lobes है, लेकिन उसका ओरिएंटेशन अलग है. Okay, we want a symmetrical part. Okay, so that's the reason we say psi2 is going to combine with what? 2pz. So this is the second combination I get. Psi2 with what? 2pz, and it results in the formation of sigma 2pz and sigma star 2pz. ये मिलेगा मुझे, alright? And as a result of which, okay, I get two bonding molecular orbitals, two anti-bonding molecular orbitals. Now when we talk about SALC दोस्तों, linear combination, 1:1. Okay, that is what we consider. So now there are no orbitals available over here on the group orbitals side. Okay, which is going to match with this. Then the 2px and 2py do not have any matching orbitals with respect to the group orbitals, and therefore they will not be involved at all in the entire process. और जो ऑर्बिटल्स शामिल ही नहीं है इस पूरे बॉन्डिंग के प्रोसेस में, उसे हम लोग क्या बोलते हैं? नॉन बॉन्डिंग. Okay, what we call it as? Non bonding. Okay, so 2px and 2py we call it as what? Non bonding. तो इस तरीके से you can find out that we get two bonding, two anti bonding and two non bonding. Clear with this part? Alright, so this is what is the introduction part which we are discussing right now with respect to the bonding of water molecule. Alright, I hope you have understood up to this very clearly. On the basis of whatever I have explained you so far, my dear friends, okay, the order of the energy of the molecular orbitals, we can show it as the order of energy of the molecular orbitals can be, we have sigma 2s, okay, having the lowest energy. Then we go for sigma 2pz. Next we talk about 2px, and the next we talk about is 2py, and then of course we talk about sigma star 2s and sigma star 2pz and all. But I am going to consider only these 4 molecular orbitals. Why? Okay, the reason I'll tell you is, this 2px and 2py are called as non-bonding. Total number of electrons हमें कितना अरेंज करना है वो बहुत इंपॉर्टेंट है. ओके, अब ऑक्सीजन के पास 6 इलेक्ट्रॉन्स है वैलेंस शेल में. एटॉमिक नंबर इज 8, but 2 electrons to be ignored because they are in the first shell. So 6 electrons of oxygen and 1 electron each of hydrogen. So 6 plus 2 कितना होता है 8. तो 8 electrons has to be arranged. So I need to have, okay, 4 molecular orbitals. Alright, so we have sigma 2s, 2 electrons, sigma 2pz, 2 electrons. Now 2px and 2py, both of them are non-bonding, so directly the pairing will not take place, but eventually of course, okay, when we write down the entire electronic configuration, yes, okay, we will be showing pairing of electrons. लेकिन दिखाने का कैसा है, 4 इलेक्ट्रॉन्स इधर आया, 5वां इलेक्ट्रॉन 2px में जाएगा, 6वां इलेक्ट्रॉन 2py में जाएगा, okay, because both of them have got the same energy, because both of them are p orbitals and both of them are non-bonding. So according to one's rule, okay, we need to follow that. So 2 and 2 is 4, 5, 6. 7वां इलेक्ट्रॉन 2px में जाएगा, 8वां इलेक्ट्रॉन 2py में जाएगा. तो ऐसा सीक्वेंस है. But at the end of the day, when you write down the electronic configuration, it is this way. Okay, so this is what the order of the energy as well as the electronic configuration, okay, as far as the water molecule is concerned. Okay, this is what we can show. Alright? But then my dear friends, remember one very important thing, and that is, whenever we talk about the energy of the molecular orbitals, it is, energy of the molecular orbitals is related to bond angle. Okay? And the bond angle is related to geometry. So on the basis of whatever I have discussed so far, and on the basis of the order of these energy of the molecular orbitals, we say that this will have a bond angle of 180 degree. Okay? How much the bond angle should come out to be? 180 degree. Okay? And therefore, the geometry has to be what? Linear. Geometry क्या होना चाहिए? Linear होना चाहिए. ठीक है? But every one of you know that water molecule is not linear. It is angular. And it is experimentally proved. ऐसा नहीं कि हाँ ये एंगुलर में बहुत अच्छा दिखता है, सर हम उसको एक एंगुलर ज्योमेट्री दे देते, नहीं. ओके, इट इज बीइंग एक्सपेरिमेंटली प्रूव्ड. ओके, तो देखो थियरी क्या बोल रहा है, वट एवर वी हैव डिस्कस सो फार ऑन द बेसिस ऑफ द थियोरेटिकल इंटरप्रिटेशंस, के water molecule is linear with a bond angle of 180 degree if the water molecule has got this order of energy of the molecular orbitals. But experiment says that it is not linear, it is angular. And experimental results are the actual results. Okay, so therefore, in order to make sure that the theoretical approach matches with the experimental observations, we have to bring about some changes in the theoretical aspects. समझ में है? अगर मेरे पास एक थियोरेटिकल डेटा है और मेरे पास एक्सपेरिमेंटल डेटा है और अगर वो मैच नहीं हो रहा है तो मुझे थियोरी में कुछ चेंजेस लेके आना होगा ताकि वो थियोरेटिकल रिजल्ट्स इस एक्सपेरिमेंटल रिजल्ट के साथ मैच हो जाए. आई बात समझ में? जो हमें वाटर मॉलिक्यूल में डिस्कस करना है. बेरिलियम हाइड्राइड में ऐसा नहीं था. बेरिलियम हाइड्राइड में एक्सपेरिमेंटल भी वो बोलता है कि इट इज गोइंग टू बी 180 डिग्री एंड द मॉलिक्यूल इज लीनियर, और यहाँ पर थियरी भी वही बोलता है कि इट इज गोइंग टू बी 180 डिग्री बॉन्ड एंगल एंड इट इज गोइंग टू बी लीनियर. सो the entire process was very easy for the discussion of beryllium hydride molecule. But it is not over here. Here there is mismatch, okay, in the both the datas. So we want to equate that. So what we need to bring about the change? Not in the experiment, my dear friends. It has to be brought a change in what? Theory part. Okay? So अभी theory में कुछ अभी changes लाना होगा. अब देखिए दोस्तों, ये जो मुझे कॉन्फ़िगरेशन मिला हुआ है, दैट आई अज्यूम दैट इट इज गोइंग टू बी ओनली 1:1 कॉम्बिनेशन टेकिंग प्लेस. मतलब वन ग्रुप ऑर्बिटल इज गोइंग टू मिक्स विद ओनली एंड ओनली वन ऑर्बिटल ऑफ द सेंट्रल एटम, दैट इज ऑक्सीजन. इसके बेसिस पे आई केम टू दिस कंक्लूजन व्हिच इज रॉन्ग. So I need to bring about some modifications in that. वो 1:1 वाला जो मैंने कंसेप्ट यूज किया था, वहां पर मुझे कोई ना कोई चेंजेस लाना पड़ेगा. Okay, तो पहले I just explain the entire process how it is much more through a diagram so that it becomes very easy for you to understand. Alright, and that is first of all हम क्या करेंगे कि एक linear water molecule देखेंगे कैसा होता है. Okay, in a linear water molecule, oxygen is going to be at the center. Everybody knows about this. Okay, next is what we have is I showed the orbital of oxygen. Because it is dimension, so I hope you understand this very well. That which am I talking about? Yes, I am talking about the 2pz. And this I am going to talk about is 2px. 2py, now please be very clear. 2py nowhere comes in the picture. याद रखिएगा. Okay, as we are discussing to bring about some modifications from a theoretical observation to an experimental observation, 2py comes nowhere in the picture, so we keep it aside. Okay, otherwise there will be a lot of complexities in the diagram and all that, so I want to avoid it. Okay, I want to keep it as simple as possible for you, my dear friends, because that is what the purpose of mine is. Okay, as I always tell you, my videos are much more students objective. Okay, so I want to make sure that the students understands this very well, and if they understand it, okay, that's it, my purpose is done. Okay, so this is oxygen at the center. We have the 2px orbital, these are the 2pz orbital. Now we talk about the 1s orbital of hydrogen, so we show it like this. Okay, we show the 1s orbital of hydrogen. Okay, now this is going to be an overlapping taking place. It's going to be a sigma overlapping. This also is going to be a sigma overlapping. Okay, so this is 1s of hydrogen and resulting in the formation of an H2O molecule. Okay, so what happens over here, if you can see very clearly, the 1s orbital of hydrogen in the linear configuration doesn't come in contact with the 2px orbital. This is the 2px orbital of oxygen. Okay, and this is the 2pz orbital of oxygen. So nowhere, see, there is no contact at all, and therefore I said 2px is going to be what? Non-bonding. Okay, according to this configuration, which results in what? The linear geometry with a bond angle of 180 degree. Understood this? Okay, now this is wrong. Okay, we need to bring about some modifications in this. Alright, so this is the z-axis and this is what the x-axis is. So now what happens is, as we go from a linear geometry to an angular geometry, okay, अगर मैं आपको यहाँ पर शॉर्ट में बता दूँ तो आपको जल्दी समझेगा, ये linear geometry है और ये angular geometry है, बराबर है? तो if you go from a linear geometry to an angular geometry, first thing is there is no change in the position of the oxygen atoms, so that is going to be as it is. Okay, ये इसको ऐसे ही रख देते हैं इसको. Alright? अब क्या होता है देखो, there is a change in the position of the hydrogen atoms. Okay, ये z axis है, आप जानते हो अच्छी तरीके से. Okay, and this is going to be what? The x axis. ये x axis है. ठीक है, ये पूरा x axis है. And this is z. So as we go from a linear to the angular geometry, what I can say is the hydrogen atoms movement is there. ठीक है, लेकिन उसे with respect to axis कैसे बनेंगे ये मैं आपको बताना चाहता हूँ. This is z and x, z and x axis. So when the hydrogen atoms, okay, what I can say is two ways. Number one, the hydrogen atom is going away from the z-axis. Okay, ये पहला पॉइंट. Okay, मैं वापस से बता देता हूँ आप लोगों को. I'm trying to make it as simple as possible. Linear molecule से, linear geometry से angular geometry की तरफ हम जाएंगे, तो you can see very well there is a change in the position of the hydrogen atoms. So how that change can be represented with respect to the axis? तो वो मैं आपको बता रहा हूँ. So the first one I can say is there are two statements for this. The first statement is that as we go from a linear to the angular geometry, the hydrogen atom goes away from the z-axis. देखो ऐसे जा रहा है. It is away from the z-axis. I can also say one more thing, and that is, okay, the second statement is the hydrogen atom is going towards the x-axis, away from z and towards x. इस तरीके से मैं दो स्टेटमेंट दे सकता हूं which actually tells you about in what direction the hydrogen atoms are moving as we go from the linear configuration to the angular configuration, and that is what I want to show over here. Okay, मुझे यहां पर वही दिखाना है. तो ऑक्सीजन is going to be at the center. ये x axis है, ये z axis है. Okay, so now मैं ये 2pz ऑर्बिटल्स बता रहा हूं और यहां पर मैं बताऊंगा the 2px ऑर्बिटल्स. ठीक है, so this is 2pz. I show bifurcation so you understand. This is 2pz and this is 2px. Okay, so now what will happen is this is the positive side of the 2px and this is the negative side of 2px. Alright, so now have a look at it. This is the way it is going to be. ठीक है, ये 1s orbital of hydrogen है, ये 1s orbital of hydrogen. So you can see, check it out, it is going away from z-axis and towards what? x-axis. So as a result of it, see, there is an overlapping taking place over here also. देखो 2pz के साथ भी उसका overlapping है. It's not that its overlapping is being broken down. No, it is there. Okay, but in addition now what is happening is to a certain extent it is overlapping with the 2px. जो इधर नहीं था, ये देखो, इधर कहीं पर इंटरेक्शन ही नहीं है between the 1s orbital of hydrogen and the 2px orbital. But यहाँ पर, see, it is involved in this. And because it is everywhere plus plus plus, so same signs. So same sign will combine with each other. So it results in strength. And when it is resulting in strength, it results in stability. And when it results in stability, it has to be a bonding molecular orbital. Okay, it cannot be an anti-bonding molecular orbital. Because anti-bonding molecular orbital is related towards weakness. Okay, as compared to the bonding part. तो इस तरीके से आप देख सकते हो the 1s orbital of the two hydrogen atoms going away from the z-axis and towards the positive side of the x-axis, okay, of the 2px axis, and as a result of which what we say is it is involved in bonding, and that too also कौन सा bonding है? Yes, it's bonding molecular orbital. It's not anti-bonding. Okay, so what is the change now which we can see from here? Okay, यहाँ पर देखो क्या हुआ था, linear configuration we had 2px and 2py. So 2px was what? Non-bonding. But now it is being involved in this particular process. So as a result of which, what is going to happen, that I'll tell you, and that is, if I'm going to show by means of energy level diagram, this is the bonding molecular orbital, this is the non-bonding, and this is anti-bonding molecular orbital. Okay, this is what the energy level is. Okay, I hope you know this very well. Okay, so bonding molecular orbital will be having lowest energy, no change as far as the energy of the non-bonding is concerned because it is not involved in the process at all. और anti-bonding है तो obviously उसका energy level is going to be high. ठीक है, तो ऐसा energy levels होता है. अब क्या हो रहा है, जैसे मैं linear से, this is a linear configuration and this is an angular configuration. So as I'm going from a linear to an angular configuration, 2px which was non-bonding is now getting converted into what? Bonding molecular orbital. क्यों bonding? क्योंकि मैंने बोला है, I specified that the 1s orbital of hydrogen is going towards the positive side of the 2px. और ये 1s वाला भी दोनों positive है, मतलब आपको समझ में आ गया होगा. Which group orbital am I talking about? Oh yes, it's psi1. Okay, क्योंकि psi2 में क्या था? One was plus and the other one was minus. Okay, so psi1 में both of them, 1s orbital of HA as well as HB, both of them have got positive. So it is the psi1 which is involved over here. Okay, in the combination. आई बात समझ में? So what happens is, देखो यहाँ पर क्या हो रहा है कि we are going from a non-bonding to a bonding molecular orbital. So as a result of which we are going down. हम नॉन बॉन्डिंग से बॉन्डिंग मॉलिक्यूलर ऑर्बिटल की तरफ जा रहे हैं. When we are going down, so that means what we say, the energy is going down, energy is decreasing, and if the energy is decreasing, so obviously you know very well the stability will increase. and therefore we say the water molecule is stable in the angular configuration as compared to that of the linear configuration, because as we go from a linear configuration to the angular configuration, the non-bonding is getting converted into a bonding molecular orbital, resulting in a decrease in energy and increase in stability. बोलो समझ में आया? Okay, so this is what the modification we have done, ताकि okay, this explanation can satisfactorily explain or give you the hypothesis for the experimental observations. क्योंकि experiment से जो मुझे observation है, मुझे कहीं ना कहीं तो उसको validate करना पड़ेगा. Okay, I need to validate that because it's not wrong, it's actual one. Okay, so I have to bring about some changes in the theory so that it validates the observations which are being obtained from the experiment. तो ये हम लोग ने change किया है. So that 1:1 combination which was there, okay, so that is not going to be considered now, and now we say the psi1 molecular orbital, okay, is now involved in a multiple overlapping. Okay, rather than a 1:1 overlapping, it is involved what? In a multiple overlapping. So it was involved in a overlapping with the 2s orbital. अभी 2s के साथ साथ it is now also involved in the overlapping with the 2px. Okay, so it is overlapping with 2s as well as 2px, and because of this multiple overlapping, we can satisfactorily explain over here that the non-bonding is getting converted into what? Bonding. Alright, and thereby it results in stability. समझ में आया? Okay, I guess up to this part is very clear to every one of you. Alright, my dear friends, now we have understood that as we go from a linear configuration to angular configuration, the non-bonding gets converted into bonding molecular orbital. So what happens is the energy gets lowered and stability increases. Now we'll try to understand in this after the changes that we have done. Okay, we go into the wave functions. Okay, ये जो हम लोग ने modifications किया है, उसके बाद अभी हम लोग wave functions के बारे में बात करेंगे. तो psi1 involves a combination with 2s के साथ तो था ही, and plus it is also going to combine with 2px. So psi1, 2s and 2px. So there are three of the orbitals which are involved. 2s and 2px are of the oxygen and psi1 is a group orbital. So obviously जितने involved है combination में उतना molecular orbitals मिलेगा. So we'll be getting 3 of the molecular orbitals. Not with respect to energy over here, so please be very careful. Okay? अब इसमें से what will happen is, because hydrogen atom is involved in the combination, so we consider it as a sigma bond. Okay? Now, whenever combination takes place, it will result in bonding as well as anti-bonding. लेकिन यहाँ पर तो there are 3 molecular orbitals. We cannot say 1.5 bonding and 1.5 is anti-bonding. And that is not possible. Alright? So it will be what? 2:1. Now we need to find out that which will be bonding and which will be anti-bonding. अब देखिए दोस्तों, whatever the modification that was being done, okay, what is the final outcome of that is higher stability. Okay, because the energy got lowered, non-bonding getting converted into bonding, so energy got lowered, so stability rises. Alright, so that was the final outcome of all the discussion of the entire part. Okay, that is, there is an increase in the stability. Now, when there is an increase in the stability, so my dear friends, it is very clear, for stability, the bonding molecular orbital are responsible. It's not the anti-bonding molecular orbital. Alright, so as a result of which what we say is, that in this particular case, if you want to make it as 2:1, so we'll make it as 2 bonding and 1 anti-bonding. Okay, that is the first conclusion we can draw. The another conclusion that can be drawn is now, okay, which one will be contributing towards anti-bonding. That is also more important. Okay, whether it is going to be 2s or whether it is going to be 2px, that will be involved in anti-bonding. Okay, तो इसके लिए बहुत simple है दोस्तों. 2s and 2px ये अगर आप देख लो, तो 2s is much more closer to the nucleus, it's more stable as compared to that of 2p. तो आपको इसका भी आंसर मिल गया. Okay, so because the 2p is far away from the nucleus as compared to 2s, so that means it is going to be less stable as compared to 2s. Okay, I'm using the word all comparative terms. And therefore, the एक anti-bonding जो है वो कौन सा होगा? 2px का होगा. Okay, so the matter is sorted out. So we have now, I'll show here the 2 oxygen. This will be sigma 2s. This will be sigma 2px. And then we have sigma star 2px. Okay, so bonding as well as anti-bonding. Now here what we are going to do is that we are going to show the elements there are going to be 2 oxygen, and then there will be HA as well as HB. Okay, so I'll be showing brackets over here. आपको मालूम है पिछले वीडियो में मैंने ऑलरेडी बता दिया है, ब्रैकेट है, दैट मींस दे आर गोइंग टू रिसेंबल व्हाट, द ऑर्बिटल्स ऑफ द पेरिफेरल एटम्स. और उसके लिए कोई टेंशन नहीं है, psi1s है एवरीवेयर एंड दैट इज आल्सो प्लस. आई होप यू रिमेंबर psi1, याद आ रहा है, दोनों जगह पर प्लस था. ओके, सो इट इज psi1s प्लस psi1s, psi1s plus psi1s. Okay, whenever we talk about hydrogen, it's very simple because hydrogen has got only one orbital and that is 1s. Okay, and this becomes the wave functions with respect to what, the group orbitals. Now coming back to the oxygen one, the first one is sigma 2s, so psi 2s, और second one is psi 2px. तो सब जगह ये लिख दीजिए आप लोग, everywhere write down the wave functions. Now coming to the signs. Okay, now see, if you go for, मैं आपको एकदम सिंपल तरीका बता देता हूँ. Okay, I don't want to go into the more technical aspect and this video will become much more longer. Okay, मुझे तो आप लोग को, मैंने आपको पहले ही बोला कि मैं स्टूडेंट पॉइंट ऑफ व्यू से वीडियो बनाता हूँ, तो आप लोग को जल्द से जल्द समझ में आ जाए. Okay, और याद रखने का एक सिंपल तरीका बता देता हूँ, यानी आपको बाहर करने की भी ज़रूरत नहीं है. Okay, तो वैसे लॉजिक लगाकर मैं आपको एक्सप्लेन कर रहा हूँ. Okay, because if I go for a technical explanation, it becomes very long. Okay, and sometimes if it becomes very long, sometimes then it becomes very difficult to grasp also. Okay, तो इसलिए मैं आपको एकदम लॉजिकली मैं एक शॉर्टकट बता रहा हूँ, वो सिर्फ आप लोग यहाँ पर समझ लीजिए. Okay, because you are going to write the science perfectly. Okay, you are not supposed to give the entire explanation about why those signs are so and so. Okay, that is not expected in the answer. Alright, तो देखो मैं आपको कैसे बता रहा हूँ. ये तीनों जो मॉलिक्यूलर ऑर्बिटल है, तीनों का एनर्जी लेवल आर डिफरेंट. इसका द एनर्जी लेवल इज हाईएस्ट, ये तो आप जानते हैं, बिकॉज इट इज एंटी बॉन्डिंग. ओके, सो हाईएस्ट वो. अब बोथ ऑफ देम आर बॉन्डिंग, बट बिकॉज वन इज एस एंड द अदर वन इज पी, सो ऑब्वियसली वंस अगेन देयर इज अ डिफरेंस इन एनर्जी. ओके, तो सिग्मा 2s विल बी मोस्ट स्टेबल. उसके बाद सेकंड नंबर पे आता है सिग्मा 2px और लास्ट नंबर पे आएगा सिग्मा स्टार 2px व्हेन इट कम्स टू स्टेबिलिटी. सॉर्टेड आउट. ओके, ये क्लियर हो गया आप लोगों को. ओके, तो नेक्स्ट इज, इसके बाद क्या याद रखने का है, how that sign should reflect the stability. Okay, मैंने आपको ऑर्डर तो बता दिया. Most stable is sigma 2s and the least stable is sigma star 2px. Now how should we do it with respect to the sign now? Okay, and that is because there are signs required over here and over here. अभी आपको मालूम है प्लस strength. Okay, minus means weakness. ये याद है बस, तो उसके हिसाब से we need to start. Okay, signs को relate करो with respect to the strength. So highest strength is sigma 2s. Strength means it is plus. So there will be no negativity at all over here. और दोस्तों ये बात याद रखिएगा. ये देखो, ये क्या है, orbital of the central atom. ये क्या है, the group orbitals. And when both of them combines with each other, it results in a molecular orbital. I hope you know this very well. Okay, and then that molecular orbital will be bonding as well as anti-bonding. तो ये वाला जो साइन है ना बिटवीन द सेंट्रल एटम ऑर्बिटल्स एंड द ग्रुप ऑर्बिटल्स, दैट डिपेंड्स अपॉन वेदर इट इज बॉन्डिंग और एंटी बॉन्डिंग. तो देखो ये वाला भी बॉन्डिंग है तो इधर भी प्लस आएगा, लेकिन ये एंटी बॉन्डिंग है तो इधर क्या आएगा, माइनस. समझ में आ गया. ओके, दिस साइंस व्हिच आई हैव शोन. ओके, आई जस्ट रिमूव दिस फॉर अ मोमेंट. ओके, तो अभी देखो ये, ओके, प्लस प्लस माइनस, आई एम टॉकिंग अबाउट दोस साइन. Those signs will depend upon whether the corresponding molecular orbital is bonding or anti-bonding. If it is a bonding molecular orbital, it will be a plus sign. If it is an anti-bonding molecular orbital, it will be a minus sign. And how to find out? Simple, star without star. Okay, तो ये without star है तो bonding है, तो bonding है तो plus. Okay, ये star है मतलब anti-bonding है तो क्या हुआ, minus. Sorted out? Right. Okay, next is, वापस से याद रखिएगा, with respect to the signs I need to show that yes, this is the most stronger, most stable, then comes this and then comes this. तो obviously यहाँ पे तो नेगेटिविटी का सवाल ही नहीं होता because it is the strongest. Okay, तो ये हो गया प्लस प्लस, so दोनों पॉजिटिव हो गया, so highest. अब इधर मैं प्लस करूंगा नहीं चलेगा, so that means what I'll say is both of them have got the same strength. No ways, because the 2s and 2px they do not have the same strength. ओके, तो फिर क्या करना पड़ेगा, समझा ना. ओ यस, देखो ऐसा लॉजिक याद रखने का. अगर यहाँ पे माइनस साइन लगा दिया तो इससे क्लियर हो जाता है कि 2px ओके इज लेस स्टेबल एज कंपेयर टू व्हाट 2s. क्लियर. अब यहां पर भी समझेगा आप लोगों को, सिग्मा स्टार हाईली अनस्टेबल, ओके, वीकनेस है, सो दैट मीन्स सब नेगेटिविटी है वहां पर, दैट्स इट, ओके। इस तरीके से याद रखोगे ना, देन आई थिंक यू विल नेवर मेक एनी मिस्टेक्स, okay, as far as this signs are concerned, and you need not memorize magita, okay। बहुत लोग वो बायार करते हैं, रटफाई कर लेंगे, हो जाएगा, ये सारी चीज़ें नहीं होती है दोस्तों इस तरीके से, ओके। हाँ, कुछ लॉजिक यहाँ पर हम लोग, मैं बता रहा हूँ आप लोगों को ताकि आपको इजीली याद रह जाए, ओके, इसलिए मैंने इस तरीके से आपको एक्सप्लेन करके बताया, ओके। उसका टेक्निकल एक्सप्लेनेशन इज समथिंग विच इज वेरी वास्ट एंड विच आई गेस, ओके, एट द एंड ऑफ द डे आवर आउटकम इज मोर इंपॉर्टेंट, आवर डेस्टिनेशन इज मोर इंपॉर्टेंट, ठीक है। तो अपना आउटकम में क्या आना चाहिए, ये साइन में किधर गड़बड़ नहीं होना चाहिए, तो इसको मैंने एक लॉजिक लगाकर आपको एक्सप्लेन करने की कोशिश की है ताकि आप जल्दी से जल्दी और इजीली समझ जाओ। आई बात समझ में, ओके। सो दिस इज व्हाट इट इज, ओके। सो नेक्स्ट इज वी गोइंग टू, ये तो इट इज एज कॉपी पेस्ट है विद रिस्पेक्ट टू बेरिलियम हाइड्राइड, Psi2N2Pz, so it will result in sigma 2Pz, and the other one will be sigma star 2Pz. Okay, next is there will be only one oxygen, and then there will be Ha as well as Hb bracket. Okay, this will be Psi2Pz, this will be Psi2Pz. यहाँ पर no doubts at all, Psi1s, Psi1s. ओके, बहुत लोग बोलते हैं इधर Psi1 है, इधर Psi1s है, तो इधर Psi2 हो गया तो इधर भी Psi2 होना चाहिए, नहीं, इसलिए मैं बोलता हूँ ट्राई टू अंडरस्टैंड, ओके, व्हाट एग्जैक्टली वी आर राइटिंग। यहाँ पर वी आर राइटिंग द वेव फंक्शंस ऑफ द ऑर्बिटल्स ऑफ दोस कॉरस्पॉन्डिंग एलिमेंट्स। तो जब हम हाइड्रोजन की बात करेंगे तो कैसे 2s आएगा, ओके, व्हेन हाइड्रोजन हैज गॉट ओनली वन ऑर्बिटल, ओके। सो प्लीज ट्राई टू अंडरस्टैंड दिस, इट्स नथिंग टू डू विद दिस नंबर एंड दिस नंबर, याद रखिएगा, ओके। नेक्स्ट इज when you talk about Psi2, if you remember, Ha was plus and Hb was minus, so we showed this way, okay, no need to show plus sign because by default you understand it is plus. अब जैसे मैंने बोला था, this is a group orbital and this is a I'm so sorry, this is the orbital of the central atom, these are group orbitals, दोनों combine होगा, molecular orbital देगा। अब इधर का जो sign है, okay, the one which is between the central atom orbital and the group orbital, that depends upon whether it is bonding or anti bonding। तो ये देखो, ये सिग्मा है तो बॉन्डिंग है तो प्लस साइन, ये सिग्मा स्टार है तो एंटी बॉन्डिंग है तो ऑब्वियसली क्या साइन आएगा, माइनस साइन। वीकनेस एंड स्ट्रेंथ, ये याद रखना है आप लोगों को, ऑलराइट। सो दिस इज व्हाट इज द वेव फंक्शंस ऑफ द molecular orbitals that we get after the improvement or after the modification that we have done, ताकि हम ये साबित कर सके कि water molecule in the angular configuration is going to be most stable। तो ये इस तरीके से आपको देख सकते हो, total we have got 5 molecular orbitals, okay, they are all delocalized, okay। So 1, 2, 3, 4, 5, out of which 1, 2 and 3 are going to be what, bonding, and the 2 of them are going to be what, anti-bonding। और एक बात याद रखिएगा, वो एक बाकी है 2py, that is non bonding, ओके। और इसके बारे में तो कोई जिक्र करना ही नहीं, मैंने आपको पहले भी बोला, it is non bonding in linear, it is non bonding even in which one, angular, all right। So I hope you have understood the wave functions of the water molecule। Now, as I said earlier in this particular video, that the energy of the molecular orbitals is related to the bond angle of the molecule. Energy of molecular orbital is what? Related to the bond angle of the molecule. And this correlation is being shown by means of a diagram. And the diagram is known as Walsh correlation diagram, which we just signified as what? WCD. Alright? So Walsh correlation diagram is a correlation diagram which is going to represent the relationship between the bond angle of the molecule with that of the energy of the molecular orbitals. So let us try to consider the Walsh correlation diagram over here. So what we do is, on one side we show the bond angle, okay, so that means we talk about, say, a molecule which is triatomic, and hydrogen are peripheral atoms or surrounding atoms. So HAH. Okay. On one side it is 180 degree, on the other side we say it is 90 degree. Okay, because that is what the maximum that we can go for. Okay, so if it is a linear molecule with 180 degree like this, or else we can be showed like this, 90 degree. You cannot have lesser than that. So this is what the bond angle is. On the other side we have got energy. Okay. So now, when we talk about 180 degree, let us take an example of beryllium hydride. So we had a sigma 2s orbital, okay, at the lowest side. Then we had sigma 2pz, and then we had over here the 2px as well as the 2py, okay, which were non-bonding. Okay, so this was the level. Now what happens is, as we go from the linear to the angular geometry, the hydrogen atoms comes closer, the s and the s, okay, orbitals of the hydrogen is going to come closer, and that results in a slightly stabilization, okay, of these 2s, a slight stabilization. So I show a energy level over here which is slightly below it, and then I will show it this way. So this will be sigma 2s for the angular one. Alright, now what happens is, as I told you, the sigma 2pz, what will happen to that particular energy of the molecular orbital? As I told you, that the hydrogen atoms, in case of water molecule, that the hydrogen atom is going away from the z-axis. So the extent of overlapping decreases. Extent of overlapping decreases, so what will happen is, the energy will rise. So it is destabilized. Okay, so I show the energy level somewhere over here, and this will be sigma 2pz. Next thing is, when we talk about 2px, in the linear geometry 2px was not involved anywhere, so that's why we say it is non-bonding. Okay, but now what happens is, in a water molecule, that non-bonding gets converted into bonding. Okay, the 1s orbital of the hydrogen is overlapping with the positive side of the 2px. I have shown you by means of a diagram in this particular video. So as a result of which, what happens is, it is involved in bonding, it is a bonding molecular orbital, so energy decreases and stabilization increases. So we show it somewhere over here. So this is sigma 2pz. I'm sorry, sigma 2px. 2py remains as it is, no change. Okay, in the entire discussion, so it's a straight line. Alright, so this is what we talk about, the Walsh correlation diagram. Okay, where this is the angular side and this is the linear side. So as we go from the linear to the angular geometry, the 2s orbital is slightly stabilized. Okay, because the hydrogen atoms comes closer as compared to that in case of the linear. Next one is the 2pz orbital gets destabilized. Okay, because the hydrogen atoms are going away from the z-axis, and therefore the energy level rises. The 2px gets stabilized, so therefore the energy goes down, because the non-bonding, here I write down it's non-bonding, the non-bonding gets converted into bonding. Okay, so that is stabilization. And the last point is, there is no change at all in the energy of the 2py, because it was non-bonding in the linear configuration, it is non-bonding in the angular configuration as well. Alright, so this is what the Walsh correlation diagram is. So from this it is very clear that how the changes are taking place in the energy of the molecular orbital with the change in the bond angle. So from 180 degree to 90 degree, these are what the changes taking place. And if the bond angle is going to change, my dear friends, the geometry is also going to change. So 180 degree is considered as linear and a 90 degree is a angular geometry. Alright, so I hope we have understood this Walsh correlation diagram very well. My dear friends, now we come to the final part, and that is the most important one, and that is about drawing of the molecular orbital diagram. Okay, so I will draw it in front of you so you actually understand how that molecular orbital has to be drawn. Alright, so first and the most important is, it is with respect to what? Energy. And please make sure one thing, and that is in the answer sheet, please use the entire sheet to draw the diagram very well. Okay, at times we see that, you know, the students just scribble around the molecular orbital diagram in such a small space which is available. No, please don't do that. Okay, use the entire sheet, okay, which is being provided to you by the university, alright, and accordingly draw it very nicely. Alright, so this is with respect to the energy. So as you go from the lower side to the higher side, the energy increases. Okay, next is, on one side we show atomic orbitals of oxygen, and here we show the group orbitals of the two hydrogen atoms. And then at the center, obviously it is molecular orbital of water molecule. Alright, now when we go into the energy levels, okay, I'll tell you one important thing, and that is, when you talk about electronegativity, so electronegativity of oxygen is greater as compared to that of hydrogen. Next, the electron gain enthalpy of oxygen is greater as compared to that of hydrogen. Okay, so much more amount of energy is released in case of oxygen. और अगर ज़्यादा से ज़्यादा एनर्जी रिलीज हुआ है तो उसके पास एनर्जी कम बचेगा, और इसलिए हम लोग बोलेंगे कि ऑक्सीजन एटम्स के जो ऑर्बिटल्स है उसका एनर्जी लेवल नीचे होगा एज कंपेयर टू द 1s ऑर्बिटल ऑफ हाइड्रोजन. Okay, so oxygen is more electronegative, it is having a higher negative value of the electron gain enthalpy, and therefore the atomic orbitals of oxygen is at a lower level as compared to hydrogen. ये बात याद रखिएगा, comparison कर रहे हैं हम यहाँ पर. Okay, it's all comparative. ठीक है? So we are going to show now the 2s orbitals of oxygen and the 2p orbital of oxygen. 2p orbitals are of 3 types: 2px, 2py, 2pz, and this is 2s. Alright? And then we'll be showing here the psi1 and the psi2 of hydrogen. Now the energy difference between the two is very less. Please be very clear. There is a difference, but the energy difference is less, okay, between psi1 and psi2. Okay, so the first combination was, if you can recollect, it was psi1 combining with what? 2s. Okay, that was the combination that we were discussing. So this gives you sigma 2s. Okay, psi1 combining with what? 2s. Okay, it is going to give you that. Next one is, that is, we have 2pz. So 2pz is going to combine with psi2. Sigma 2pz. Next is we have 2px. Now for 2px what we need to do is, we also have to relate this with this. Because here in this combination, if you can recollect, we had to psi1 we join it. So psi1, 2s and 2px. So that is going to give you sigma 2px. Next, straight line, and that is going to be the non-bonding 2py. Okay, then we had the anti-bonding. So anti-bonding we have is sigma star 2pz, and then we have sigma star 2px. So sigma star 2pz will go with psi2, and it will be connected with this. And then the last one is this is sigma star 2px, this is sigma star 2pz, and also we need to show its connection with So 2px is going to be shown with the connections of all of these. Okay, also with respect to sigma 2s. Okay, we are going to show that. So connect this also. So for sigma 2s, the combination was, if you can remember, psi 1. Okay, so see, it is connected with psi 1, 2s and 2px. Okay, 2pz, it was simple, it was psi 2 and 2pz. For 2px, sigma 2px, it was psi 1, 2s and 2px. Okay, 2py non-bonding, so you need to connect it only with the oxygen, no other connections on this side. Sigma star 2pz, once again it's very clear, it is going to be connected with psi 2 and it is connected with 2pz. Sigma star 2px, it has to be connected with what? 3 of them, 2px, 2s and psi 1. Okay, this is what the entire connection is. So I hope you are being very clear with the molecular orbital diagram. Okay, now you need to show the arrangement of electrons. First, always show the arrangement of the electrons in the atomic orbital and the group orbital, and then you show, okay, with respect to what? The molecular orbital. कई बार दोस्तों ये देखा गया है कि हम लोग जब पेपर चेक करते हैं तो atomic orbitals on the either side खाली है. Okay, molecular orbital भरा हुआ electrons. तो कैसे आया वो? Electrons आया कहाँ से फिर? ओके, अगर ग्रुप ऑर्बिटल में और एटॉमिक ऑर्बिटल ऑफ द सेंट्रल एटम में इलेक्ट्रॉन ही नहीं है तो मॉलिक्यूलर ऑर्बिटल में इलेक्ट्रॉन आया कहां से? क्योंकि क्या होता है, दिमाग में ऐसा भरा हुआ है, यस मॉलिक्यूलर ऑर्बिटल डायग्राम, मॉलिक्यूलर ऑर्बिटल डायग्राम, तो इस वजह से बच्चे ऐसे में गड़बड़ करते थे. तो प्लीज डोंट डू दैट. सो सीक्वेंस इज फर्स्ट इज एटॉमिक ऑर्बिटल एंड ग्रुप ऑर्बिटल एंड देन यू शो द फिलिंग अप ऑफ इलेक्ट्रॉन्स इन द मॉलिक्यूलर ऑर्बिटल. सो 2s2 and 2p4 है तो 1 2 3 and the fourth electron comes over here. ठीक है? So this is the arrangement of electrons in oxygen. Hydrogen is very easy, it is 1s1. Okay, in psi 1 and psi 2 I show 1 electron because as I said psi 1 and psi 2 the energy level is less. Okay, so electrons are not going to be considered as a localized one that but both the electrons will go into psi 1 and the psi 2 will be vacant. No, it's not like that. Okay, this delocalization taking place and the energy level between psi 1 and psi 2 is very less. Okay, so that's the reason we are going to show it 1 electron each. So now how many electrons to be arranged? 1 2 3 4 5 6 7 and 8. So 8 electrons has to be arranged in the molecular orbital. Rule is very simple. Okay, हमें लोअर ऑर्बिटल से शुरू करना है और हायर ऑर्बिटल तक जाना है. नेक्स्ट थिंग इज इलेक्ट्रॉन ऊपर वाले लेवल पे तब तक नहीं जाएगा जब तक नीचे वाला ऑर्बिटल पूरा भरा हुआ नहीं है. पूरा भरा हुआ मतलब कितना? 2 इलेक्ट्रॉन. यानी द फर्स्ट 2 इलेक्ट्रॉन्स विल गो इन सिग्मा 2s, द नेक्स्ट 2 इलेक्ट्रॉन्स विल गो इन सिग्मा 2pz, द नेक्स्ट 2 इलेक्ट्रॉन्स विल गो इन सिग्मा 2px, ओके, एंड द लास्ट 2 इलेक्ट्रॉन्स विल गो इन 2py. ओके, और इस तरीके से दोस्तों द इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ द वाटर मॉलिक्यूल कैन बी गिवन एज, ओके, इलेक्ट्रॉनिक कॉन्फ़िगरेशन अगर लिखना है तो लोअर टू हायर ऑर्बिटल्स यू राइट इट डाउन व्हिच कंटेन्स इलेक्ट्रॉन्स. ओके, तो सिग्मा 2s 2, सिग्मा 2pz 2, next is sigma 2px 2 and next one is 2py non-bonding 2. So 1 2 3 4 orbitals, 4 into 2 is 8. So 8 electrons we need to arrange. Okay, so that is what is being arranged. Okay, all electrons are going to be paired. Okay, and therefore we say the water molecule is dimagnetic. Okay, on the basis of this particular theory we say it is going to be what? Dimagnetic. ठीक है? Now one question I would like to solve over here and that is सिग्मा 2pz मैंने नीचे बताया है और सिग्मा 2px ऊपर बताया. ओके, अभी थोड़ी देर पहले मैंने आपको वॉल्श कोरिलेशन डायग्राम बताया था तो उसमें क्या था कि सिग्मा 2pz का लेवल ऊपर था, सिग्मा 2px का नीचे था. लेकिन एक और बात बताना चाहता हूं वहां पे एंड दैट इज कि उस वॉल्श कोरिलेशन डायग्राम में मैंने जो बॉन्ड एंगल बताया था वो अप टू 90 डिग्री तक बताया था. So 180 degree to 90 degree. So whenever I have a molecule with a bond angle of 90 degree, तब मैं वहाँ पर ऐसा बताऊंगा कि the 2pz will be having a higher energy and the 2px will be having a lower energy. लेकिन you guys know very well that the bond angle of water molecule is not 90 degree. It is 104. So as a result of which, when you go from 180 to 104, so what happens is the sigma 2pz is going to be lower and sigma 2px is higher. Okay, that's why I have shown this way. When you go up to 90 degree, then the sigma 2pz will be at the higher level and sigma 2px will be at the lower level. तो ये मैं आप लोगों को एक क्लैरिफिकेशन देना चाहता हूँ. ओके, ये बिकॉज ऑफ द बॉन्ड एंगल ये इस तरीके के लेवल्स है. Alright, so this is the molecular orbital diagram. This is the electronic configuration of the molecule. I explained you the properties also. That is the magnetic property. And therefore, what we say is, okay, total there are going to be 4 orbitals, okay, which are containing electrons. Okay, और ये वाला part है, okay, this one. Okay, अगर आपको याद है कि if I am going to consider a linear molecule, तो I would have got only 3 levels. Q, because 2px and 2py both were considered as what? Non-bonding. So sigma 2s, sigma 2pz, that were the 2 levels, and the third level is 2px is equal to 2py. लेकिन यहाँ पर there are total now 4 levels, and this is confirmed from the photoelectron spectrum. Okay, photoelectron spectrum shows 4 bands. Okay, so which is very clear that there are going to be 4 different energy levels. Okay, तो इससे ये साबित हो जाता है. Because at the end of the day, we need to make sure that we validate the experimental results. तो फोटो इलेक्ट्रॉन स्पेक्ट्रम से क्लियरली दिखता है कि वहाँ पर 4 बैंड्स है, और वो 4 बैंड्स इसके वजह से because there are 4 different energy levels of the molecular orbitals, which wasn't there if I consider the linear molecule. और इस तरीके से ये भी साबित हो जाता है कि this configuration, क्योंकि मैंने आपको बोला कि the energy is related to what? Bond angle. And bond angle is related to what? The geometry. तो फोटो इलेक्ट्रॉन स्पेक्ट्रम से ये साबित हो जाता है कि this is the right energy levels of the molecular orbital of water molecule, and therefore we say water molecule is angular in geometry. Okay, so this is all about, okay, the water molecule. I know the description was being large enough, the video length is also going to be too big, but then I cannot break this, the water molecule, into 2 different videos. Okay, it's not possible. Okay, because it's one single molecule. Okay, एक वीडियो में मुझे एक पूरा molecule तो consider करना ही है. Alright, so please show your patience. Okay, see this entire video for a better understanding, and please do like it. Okay, and if you haven't subscribed my channel, please do so. Reason is very simple, ताकि जो आने वाले जो मॉलिक्यूल्स है इस चैप्टर में, और भी मॉलिक्यूल्स है, तो जब उसके बारे में मैं वीडियो डालूंगा तो आपको जल्द से जल्द और आसानी से उसके बारे में पता चल जाएगा. इसके लिए सब्सक्राइब करना मेरे चैनल को बहुत ज़रूरी है. सो दिस इज विपुल पुरोहित साइनिंग ऑफ नाउ, ओके, विद द एक्सप्लेनेशन ऑफ वाटर मॉलिक्यूल. आई विल सी यू नेक्स्ट टाइम विद सम अनदर मॉलिक्यूल. थैंक यू सो मच.